A group of System Dynamics Society educators and modelers. You can see their names here: Emre Gotepi, John Darko, Kim Warren, Lee Stuntz, Anne Levine, and Chris Brown, and I have started a project that we hope will be helpful to other educators and researchers who use systems thinking and system dynamics modeling in their work. We are trying to create a databank of systems thinking assessment questions that educators or researchers have used to determine the level of systems thinking understanding in their students or subjects after exposure to systems thinking lessons or experiences. Eventually, we hope to create one or more systems thinking concept inventories. It will come as no surprise that systems thinking is recognized as a very important skill for all of our futures. The United Nations published in 2019 in their Global Sustainable Development Report a statement indicating the importance of skills, including systems thinking, for students to be able to understand sustainability of Earth and living species. The purpose of the project is to provide a bank of questions for use in assessing systems thinking at primary, middle school, secondary school, and undergraduate university levels. We want to provide also researchers with a bank of questions to use to assess the improvement in systems thinking in the subjects of their experiments. As a resource for eventual development, we will use these systems thinking questions to create systems thinking concept inventories to be developed for use with pre-college students. There are 7 levels in the suggested list of systems thinking questions that we think lend themselves to assessment. For level 1, the idea is to recognize the dynamic nature of systems. Recognizing dynamic systemic systems, interpreting graphical information correctly, identifying parts of a system, identifying causal connections, explaining and or sketching important variables in a system using behavior over time graphs or words, and understanding that a system is more than the sum of its parts. Some sample questions for this first level are: identify at least 3 parts of a system that produce a flower. And here is the potential answer with possibly the grade level that might be appropriate for this type of question. Another one for causal connections among parts: draw a causal link between 2 of the following elements and show that one element causes the other element. Here is a potential answer. Another question talks about sketching a behavior over time graph for a story scenario. Students would label the axes appropriately and explain the reason for the shape chosen. Here's a potential answer for the problem shown here. For level 2, we're talking about not just recognizing, but representing the system with stocks and flows. So differentiating types of variables is very important to be able to do this. Identifying units of measure is also extremely important. Sketching a hybrid stock flow diagram, a hybrid stock flow causal loop diagram of a system would be part of this level. Using hybrid stock flow causal loop diagrams as communication tools would be part of this to explain the modeler's mental model. Understanding that structure determines behavior, using flows to explain stock behavior, using stocks to explain flow behavior, hand calculating stock flow values in sample models. Explaining bathtub dynamics. This is a big one, and you will see an example of a question of this type coming up. Identifying closed loops and capturing assumptions about a system from the view of different stakeholders. So one potential question would be to give 8 variables involved in, say, homeostasis, and ask students to identify which would be stocks, which would be flows, which would be neither of those. Here is a potential answer to that question. Next, this is about giving a scenario about a patient in an emergency room connected to an IV drip and asking students to sketch the stock flow diagram for this scenario. Here is a potential answer for that. Another question, this is a bathtub dynamics question. Given the birth and death relationship of a group of frogs over time, determine the change in the frog population over time. And here is the answer for this question. The next level is identifying feedback. Describing the polarity of a link would be part of this level. Understanding the difference between reinforcing and balancing feedback. Understanding why no feedback is possible without at least one stock in the loop. Determining loop polarity, which is very similar to item number 2 there. Identifying feedback in a stock flow diagram. Identifying dominant feedback from a graph or a stock variable over time. Another question, given a simple stock flow diagram consisting of a feedback loop, identify the polarity of the loop and explain why it has that polarity. And here is a potential answer for that question. Next, level 4, understanding dynamic behavior. In this level, we have explaining the behavior of causal relationship or stock flow diagram segment, knowing what produces linear, exponential, convergent, oscillatory, overshoot and collapse stock behavior, explaining the effect of delays. Explaining the behavior of linked feedback loops. Explaining the cause of transfer of loop dominance. And finally, explaining systemic behavior from different stakeholder perspectives. Another question, given a stock flow model diagram with descriptive element labels, explain the behavior and interaction of the 2 linked feedback loops that are identified. And this is a potential answer for that question. Now let's go to level 5, using conceptual models. The first item in this level is to recognize the transfer of structure to other relevant scenarios, including archetypes. Then, using a pre-constructed simulation to suggest potential solutions to a stated problem. Using a conceptual model sketch of a diagram, a hybrid stock flow CLD diagram, to suggest potential solutions to a problem. A question here could be using C-ROADS or some other SD simulation. You could use it to test policies to help solve a potential problem, or to suggest policies that can move you in the right direction. There are a lot of different possibilities for this situation. The next question, transfer the epidemic model structure to another relevant scenario that would reasonably have the same dynamic interactions and produce similar behavior. And these are some 2 possibilities for an answer to this question. For level 6, people are creating simulation models. The first is to represent the relationship between variables in mathematical terms. Next, to make sure the model has consistent units. This is critical for any model that is created, that is to have any value in trying to solve a problem or understand more about a problem. Next, knowing how to build and use a dimensionless multiplier when needed. And this arises a lot when models become even slightly larger than basic introductory models. Recognizing model building is an iterative process. Actually building an operational stock flow model to capture the dynamics of a scenario, operating the model that was constructed, validating a model that was constructed, and recognizing unintended consequences in model output. Potential questions here are, given a relatively simple dynamic, system scenarios with appropriate data, build a model for the scenario. Anticipate model behavior and explain any discrepancies between anticipated and actual model behavior. There are a lot of possible scenarios here. This is one that is a very simple example that could be used. Another question, given a relatively simple, well-described model, or a model that you have created, identify consistent units for the model. And those answers are shown here. Level 7, the last one, is testing policy. Hypothesizing the effect of changes made in the model for model output. Using a stock flow simulation to test the effect of policy changes whose stock flow structure you can alter. Interpreting model output. Understanding how to use model output to make real-world policy recommendations. Designing policies based on model analysis, and recognizing policy resistance. Here's a question. Given an operational simulation whose stock flow structure you understand, test a variety of policy options to select the best potential policy to solve the problem presented. And this is a potential solution to the previous question dealing with the Fishbanks model. Creating systems thinking concept inventory is the last part of this presentation. A concept inventory is a multiple choice research level instrument. It's an assessment designed to test students' conceptual understanding of a particular subject or discipline. There are 3 stages in this process. First, you create a list of core concepts. You select experts to review and score the concept importance and difficulty, and then you average the ranked concepts, and the concepts with higher averages move to stage 2. In stage 2, 20 multiple choice questions are designed with just one correct answer. Distractors should come from misconceptions about the concept. Questions should not require much or any calculation. The third stage is to test the questions. Evaluate the questions on students or subjects to ensure reliability and validity. This is one possible concept inventory question for systems thinking. Given an inflow graph and an outflow graph, what is the behavior of the stock? And there are 6 potential choices here. So we are asking for your help. Those of you who have developed systems thinking questions for your work, we ask that you would be willing to submit some of your questions for this database we are developing. No special format is required for a question you submit. It does not have to be a multiple choice question. See the URL here. It is a Google form. And on the Google form, the first page, you give us your name, your email, your permission to use the question, the actual question, the answer to the question, and the systems thinking level one of the 7 we've just listed, that you think the question belongs to. On the second page, we ask for the discipline for which the question was developed, the student age group you think appropriate for the question, the purpose of the question, the level of difficulty of the question, and if there's any prerequisite knowledge for the question. This second page is not required that you respond to, but we request that you answer those questions. The questions will be available for free through the Creative Learning Exchange. Those who submit questions will get the question database first. Thank you.